Hello friends, my name is Biswajit, your network trainer. So today I am back again with a new topic, Cisco SD-Access, SDN, Software Defined Network. So if you were aware of that in today's world, everything is managed by a software only. If you see our traditional WAN network is being taken over by the SD-WAN. So complete WAN will be taken care by the software. If you look into the data center, the Cisco has designed the ACI. So through software, the Cisco will going to be manage its own data center. Okay, and Cisco has been thinking about the enterprises network. What will be the solution for the enterprises network? How we will going to manage the enterprises network? How the enterprises network can be managed with the help of software? So now the Cisco come up with a solution which is known as Cisco SD-Access. So in this tutorial, I will give you the full introduction about the Cisco SD-Access. So this tutorial will be just an overview, and after this tutorial, you will have a clear picture in your mind that what exactly a Cisco SD-Access is. So if you have the clear overview in your mind, so the next time when I will be uploading more videos based on the Cisco SD-Access, you will have a clear understanding about what exactly a Cisco SD-Access is. Okay, and if you guys are new to my channel, then kindly subscribe to my channel and click the bell icon so that from next time onwards, whatever the new videos I will be uploading in my channel, so you are the first one who will get notified. Right? Fine. So guys, when we will learn about the new technology, there are a couple of questions that comes in our mind. Why should we learn this new technology? How this new technology will be overcome the existing problem that we have in our infrastructure, how we can deploy those technology in our existing infrastructure. So these are the couple of questions that I will be providing you answer today. So please follow my tutorial till the end. Okay, so let's start. What Cisco SD-Access is? What exactly is a Cisco SD-Access? So SD-Access is a combination of campus fabric and the Cisco DNA. So guys, you maybe heard these two terms, the campus fabric and the Cisco DNA, is the first time. So don't get confused about these two new terms, the campus fabric and the Cisco DNA. I will be explaining to you one by one. Okay, what exactly is a campus fabric? Campus fabric is a combination of two technology together, campus and then fabric. If you would like to know what is campus fabric, then we will first of all we will know about campus and then fabric. So if we know the campus and fabric, the combination, we will be able to know what is the campus fabric. Okay, so what is a campus network? Campus network is an enterprises network consisting of many LANs in one or more buildings, all connected and all usually in the same geographical area. So guys, I do have a nice picture here to make you understand. Okay, so let's say this is an organization which is XYZ, right? And for this organization, they have their own campus. Let's say this is the first building, this is the second building, and this is the third building. And you see the number of users are sitting in each building. We have the users connected in the first building, second building, as well as the third building. And there are a number of devices are also associated with this many user. Okay, and we have the LAN all around. So when we have this kind of design, when we have this kind of topology, so this kind of topology is known as the campus network. So in a single campus, this is a single campus for a organization XYZ. So in this, the area, the campus 1, campus 2, and campus 3, there are number of users. Each user are connected to a different devices. You will find a number of LAN network, and again they are connected to their backbone network. So this kind of topology that we have, it is known as the campus network. Okay, so you will find this kind of traditional campus network almost everywhere. In all of the company, you will see this kind of campus network they do have. Okay, so guys, this is the campus network. So now we have understanding about what exactly is a campus network. So campus network is nothing but is a collections of the many LANs associated with the user who are connected to a different devices, and this is spreading usually in the same geographical area and connected to their campus backbone. So as we know this is the campus network, we should also know that what are the existing problems that we have in our campus network. Okay, so if we know the problem that we have in our campus network, so we can visualize how those problems can be addressed, can be overcome by using a new technology. Okay, so existing issues in a campus network, what are they? Number one is the host mobility, stretching VLAN. Second one is the role-based access control, which is ACL. Third one is the L2 spanning tree, and then three-tier architecture, and then common policy for LAN and WLAN network. So guys, this is a topology where I will be explaining to you each of those issues that we have in our campus network. So the first one says this stretching VLAN host mobility. What does it mean? It means that let's say this is our first building, this is our second building, and this is our third building. Okay, so if a user who is sitting here, if this user would like to move to a second campus, maybe the second building, okay, and if this user in a VLAN 10, and if this VLAN is not existence in this campus network, so what we have to do, we have to create an additional VLAN here, which is the VLAN 10, and putting this user under this VLAN. This is the first task. The second task, we should allow this VLAN over the trunk link. Okay, if the user is connected to the access switch, then we have to create the VLAN in this access switch, and then if the access switch is connected with the distribution switch or maybe your core switch with the help of trunk link, then we have to allow the VLAN in both way. Okay, so this is a big task. Okay, so for the network engineer, they have to do a lot of manipulation in their network. So this is the one issues that we have. The second problem that we have, which is the role-based ACL. So it means, let's say in our organization there are thousands of ACL has been created, and there is a one person, he has created 1000 ACL, and this ACL is given to a different access to a different VLAN. And supposedly one day this person will leave your company or maybe leave your organization, and for you to maintaining this thousands ACL or maybe 10,000 ACL is a very much difficult task. I personally came across situations where there were a number of ACL, more than 5,000 ACL were configured, and when we would like to get rid of few of those ACLs, it was not easy. You cannot take everything out at a time. So you have to make a proper plan, you have to make a proper documentation, you have to make the proper time as well, and take the downtime to do those configurations. So this is again a big problem, a big task. Okay, the third issues that we have, which is the L2 spanning tree. So as you guys all know that spanning tree is one of the protocol which help us in preventing loop in our network, but it also has a disadvantages. So let's say we have the switches which is a 1900 switch, and you have also the 3600 switch, and you have configured spanning tree in both the switches. Okay, and if you guys know about the root bridge concept in spanning tree, that one switch become your root bridge. Okay, and if let's say 1900 switch has a priority, the lesser priority as compared to the 3600, then these will become your root bridge, and all the traffic will be forwarded by the 1900 switch. Though you have the more feature in the 3600 switch, but because of the spanning tree, all the traffic will be forwarding via this. So you have this suboptimal forwarding. So this is one of the issues that you have the spanning tree, and the network engineer has to spend more maximum time for identifying these issues and fixing these issues. So this is one of the issues. The fourth one, we have the three-tier architecture. So guys, you will find this kind of architecture in almost in all data center, like you will find it in the core, and then distribution, and then access. So these are all the three-tier architecture that you will find everywhere. Okay, so but nowadays this infrastructure design has been replaced with a spine and leaf nexus. So the fourth problem that we have, the common policy for LAN and WAN network. So let's say in an organization you have the LAN network and you have the WLAN network. So you have to create a different policy. For LAN network, you have to create the policy ACL in your core switch or maybe the switch firewall. For your WLAN, you have to create those policies in the your WLC controller. So this will become a heavy task for the network engineer nowadays. Okay, and let's say if your organization grow up and their number of users increase and number of devices increase, so maintaining the entire network is very much difficult, and doing troubleshootings, finding the issues in your network will become nightmare. So how can we fix those issues? So what are the different approaches that we have to take for fixing these issues? So these are the issues that we have in our existing network. So by keeping those issues in our mind, we are going to the software defined network. So the Cisco has provided the SD-Access, so which is the enterprise solution for the campus network. So what exactly is a campus network? We have learned. So now we will see what exactly is a fabric. So fabric is an overlay. Okay, overlay is a logical topology. It is used to connect all devices virtually. Fabric is built on the top of the underlay topology, and underlay provide transport mechanism. So guys, in this slide you may be getting confused over the overlay, over the underlay, what exactly the overlay is, what exactly the underlay is, what is the fabric. So don't worry, I will be explaining to you one by one. So what is underlay? So underlay is same as we have our existing campus network. So in our existing campus network, we did not make any changes. The campus network that we had earlier, the traditional campus network, we exactly has the same campus network nowadays. There was no changes been made in the campus network. You will find the traditional switches, you will find the traditional firewall, you will find the all devices there. Okay, so nothing has been changed in our campus network. So in underlay domain, when we talk about the underlay domain, so in underlay domain you will find everything as same as we have right now. Okay, so what has been changed? So only the changes has been done in approaching. So how we used to do and how we will going to do from now onwards, this approaches has been changed. Okay, and how this approaches has been changed? By creating the overlay. So what exactly is the overlay is? So overlay is a logical topology. So what is a logical topology? This is not a physical. Okay, this network is not a physical network. We have just created a logical network. Okay, and this logical network is responsible for maintaining our underlay network. This logical network is responsible for maintaining all the devices that we have in our underlying network, right? And how this overlay has been created? The overlay has been created just above the underlay. So we have the underlay and we have the overlay. In underlay we have our existing campus network, where you will find all your traditional switches, router, firewall, and above that we have created the overlay. So now the question is how the traffic will be forwarded, and what are the differences that when we used to forward the traffic and when we are forwarding the traffic. So let's say in traditional network, what we used to do, we have a core layer, and then the core is connected to a distributions, and distribution is connected to the access. So we have here the core layer, and we have the distribution layer, and we have the access layer. So this is our traditional campus network. Okay, and what changes has been made in the fabric? So the terminology has been changed. Okay, the core layer has become here the border device, okay, and then the access layer has become here the edge device, okay. So this is the topology that we have right now. Previously we used to have the access, distribution and core, but now we have the topology like this: the edge device and then we have the border device. So previously what used to happen, so let's say you have the access switch here. Let's say you have the access switch and this is your host. So when the packet will initiate from the host, the packet will come into the access switch. The packet will go through the all your layer 2 domain, and then the packet will getting forwarded either maybe the distribution layer or you have the collapse core layer maybe. So if you have a distribution, let's say the packet will be forwarded to distributions, where the packet will go through all the routing domain, and from there it will be again forwarded to the core layer, the core switch, and from core switch it will go to the internet or maybe outside or maybe MPLS. So this used to happen. So now what will happen? So let's say the edge device. So don't get confused with the edge device and the border device. Your edge device is same as with the access layer that we have in traditional network. So now the host. So the host, when the packet will initiate from the host, the packet will come and directly hit into your edge. When the packet will hit into your edge, the packet will get encapsulated by the VXLAN, which is the virtual LAN. So if you are thinking about the VXLAN and all, so I will be creating the more slide based on the VXLAN, a tutorial. You guys need to comment if you would like to know more about the VXLAN. So I will create a more slide based on the VXLAN. So when the packet will initiate from the host, the packet will directly come and hit into your edge device. Once the packet will hit into your edge device, the packet will get encapsulated by the VXLAN, and from the edge device till to the border device. So let's say this is your border device. So till to the border device, your VXLAN will carry the packet, okay, and once the packet will reach to your border device, this packet will get decapsulated, okay, and from there it will go to the outside world, or it may go to the another fabric, okay. So this task, everything will be done by the VXLAN, okay. So guys, don't worry about the VXLAN. So VXLAN is just a protocol that we are using it here. Earlier your packet has to come to the access switch, from access switch it has to go to distribution switch and then the core switch. Now your packet is coming from the host, and once the packet is heading to the edge device, from edge device the packet is going to be encapsulated by the VXLAN, and VXLAN will taking your packet forward till to the border device. So how we are creating the VXLAN here? So we are creating the VXLAN with the help of the underlying network, or with the help of the underlay network. And how we are creating the underlay network? With the help of the routing domain, which is ISIS. So guys, here in the underlay network, the protocol, the routing protocol that we are using, which is ISIS, okay. So most of you may know about the ISIS, because the question that comes in your mind, that why should we use ISIS? Can't we use any other protocol that we have? So of course we can use it, but Cisco recommendation is we should use the ISIS, okay. As you know that ISIS is not the IP level. We do not require to assign an IP address, physical IP address to an interface. So Cisco recommended is to use the ISIS. So our VXLAN is built up by the underlay network, and underlay network is going to build up by the ISIS. So I will again create another tutorial based on the ISIS, okay. So now the questions that comes in mind, that how the fabric is created. So when the VXLAN is taking the leverage of your underlay network, and in underlay network we are using the routing domain ISIS. So VXLAN combining with the ISIS, the fabric is created. The fabric is just an overlay, which is just a virtual. There is nothing physical. So from virtual we will be managing our entire network, okay. Don't get confused with the overlay and the underlay. There is nothing at the overlay, just we have the virtual shadow of your underlay network. Through this virtual network we are going to manage your underlay network. Okay, so now the question is that came in our mind is that earlier it used to be easy. We just need to configure the access switch, distribution switch, we just need to configure the VLANs and all. But now you are telling me that we have to configure the VXLAN, we have to configure the ISIS. So the question is, who will do those? Because these are very heavy terms, the VXLAN and ISIS. So configuration of VXLAN, ISIS, we have to study a lot. We have to configure these things again and again, right? So let's don't worry about this. The configuration of the VXLAN and ISIS, everything done by the automations. Automatically everything will be configured. And who will configure that automatically? This will configured by the DNA. Okay, the Cisco DNA. So I will be explaining this to you in the next slide. What is Cisco DNA, right? So Cisco DNA will take the leverage in your entire network. We just need to configure the border device, and once we configure the border device, the Cisco DNA will get into your underlay and configure the VXLAN as well as the ISIS. Everything will be automated. You don't need to do anything else. It's just a plug and play device. Okay, and in underlay network, which is just giving us the transport mechanism, because we are using the routing protocol here, ISIS, and through this ISIS the underlay network will provide only the transport mechanism. Your packet will be forwarded from one hop to another hop. So nowadays it is just only a single hop, because your end host packet will come and hit into your edge device. From edge device till to the border device there is only one hop, because your packet will be encapsulated under the VXLAN. So VXLAN will take care of everything. But earlier it used to go to the access switch, distribution switch, core switch, and many things, and there used to be lots of hops in between. Okay. So now the another question that comes in our mind is this: since you are telling that our packet will go through the lots of routing domain, will not there be a delay in routing delay while the packet will be traveled from one hop to different hop? So no, the answer of this question is no, because there will be no routing delay. Initially what we used to do, that we used to configure the routing protocol in our L3 devices. So when the packet will come to our L3 devices, based on the destination the packet used to get forwarded. Okay, the router used to see its own routing table, and if the network is present to its routing table, then the packet will get forwarded. But here this is not the scenario. Okay, because in overlay we are using a protocol which is known as LISP, which is list. Okay, so this protocol is completely responsible for taking your routing decision. So guys, this is again a new term, LISP. So I will be configuring, I will be creating another videos based on the list, right? So here what are we doing? Here we are just decoupling the control plane and data plane, right? So hope you understood about the fabric. And one more questions: what makes fabric a unique? So as I explained it to you, the control plane that we have for overlay, which is list, locator identifier separator protocol, and then we have the underlay data plane, which is the VXLAN, virtual extensible LAN, and then we have the policy plan, which is created by the Cisco TrustSec. So these are the three components which makes your fabric unique. In underlay we have the control plan. As we are decoupling the control plan and data plan from your existing campus network, so the control plan will be list and the data plan will be the VXLAN, and all the policy that we will be integrated into this infrastructure will be by Cisco TrustSec. So these are the three components which make your fabric unique. Okay, so now we understood about the campus fabric, we know about the campus network, we know about the fabric. So when we combine these two together, it becomes your campus fabric. Okay, so this is the complete diagram that you have here. So in overlay we have the list and underlay we have the VXLAN. In the routing domain, that is we have in the underlay, which is by ISIS, and all policy will be implemented into your network by the Cisco TrustSec, right? Okay. So now, as I said, everything will be done by automation, and this automation will be done by the Cisco DNA. So what exactly Cisco DNA is? So Cisco DNA stands for Digital Network Architecture, and this is the complete architecture that we have for the Cisco DNA. So what are the capabilities that the Cisco DNA provides? So it provides automation, it provides analytic, okay, it provides virtualizations, it provides the security. So most important that the capabilities that the Cisco DNA has, which is the security. So how the Cisco DNA provide the security? So there is an important component, one of the most important component that we have in Cisco DNA, which is called Cisco ISE. So we have the Cisco DNA here, and this Cisco DNA is integrated with the ISE. So my security colleague knows about what is ISE. So Cisco ISE is nothing but which provide a security in our infrastructure domain. So in the background, the DNA goes through a lot of integrations. Okay, so one of the major component is ISE. So DNA will getting integrated with the ISE and provide the security to your infrastructure. And how it's provide the automation, how it create the VXLAN, how it create the ISIS automatically without the user intervention. This is done by the TCP, which is data control plane. So the DNA is also integrated with DCP as well. Through this, it is maintaining the automation and assurance in your network. And security and compliance, for that the DNA is integrated with the ISE. And how it is provide the analytic? So the DNA is also integrated with one more component, which is known as network data plan, and this is network control plan, and this is the network data plan. Okay, so DNA is associated with your network control plan to provide the automation. DNA is associated with network data plan, this is P, for providing the analytics. So the DNA is in background, the DNA is integrated with lots of your monitoring tools where it is collecting the data and presenting those data in a presentable format or analytic format. This is a difficult task. This is done by the your machine learning or AI. Okay, so this is the architecture, guys, that we have in Cisco DNA, and let me explain it to you more about the Cisco DNA. So the component that we have in Cisco DNA, this is a structure. The component that we have fabric, as I explained it to you, what is fabric, what is EPIC EM controller. So you see the EPIC EM controller that we have, this is a physical device. Okay, so this is the physical device. So SD-Access, Cisco SD-Access. Okay, so for Cisco SD-Access, Cisco EPIC EM 2.0 is the version, and this is the hardware device. This hardware device will be sitting just top of your underlay network, and through this EPIC EM you will be maintaining the campus network. Okay, the existing campus network will be maintaining by this controller, right? And the DNA center, this is just an web based, and which will be just stop at your EPIC EM. So whenever you would like to manage the EPIC EM, you have to log into your data DNA center. Through this DNA center, you have to manage the Cisco EPIC. Okay, this is the hardware, and this is the web portal. You just need to log into your DNA center, providing your user ID and password. Through that, you will be managing the Cisco EPIC. So this is just like if you know about the Meraki, that we have a controller, right? So this is a controller which is in the physical device, and DNA is a web based. Through that, you will get into the Cisco EPIC, and from Cisco EPIC you will be maintaining your campus network, and your DNA is integrated with the Cisco ISE for providing the security, and then the Cisco NDP network data plan, through which we are providing the automation your network, and there's one more component which is network control plan, through which you are also maintaining the assurance or maybe highlighting things in your network. So I have explained to you what is Identity Service Engine, ISE, which is ICE. Network data plane, I explained it to you, and then DNS center, which is also I explained it to you. So these are the 5 components that we have in Cisco DNA. Okay, so this is an overview, guys. So I hope you understood about what the Cisco SD-Access is. So we learned today about Cisco SD-Access. Cisco SD-Access is a combination of the campus fabric and then Cisco DNA. I explained it to you what is the campus fabric. It's a combination of campus and fabric. What is a campus network? What is a fabric network? In fabric network, we have the underlay, we have the overlay. Overlay is nothing but just like a virtual. Through this, we are maintaining our underlay network. I have also explained it to you that what make the fabric unique. We have the control plan, which is maintained by the list. We have the data plan, which is an underlay network, VXLAN, and the policy which we have, which is integrated policy uh, in our network. Okay, so and then I have explained it to you about the Cisco DNA, what exactly the Cisco DNA is, and what is the architecture of the Cisco DNA. So Cisco DNA is nothing but this is just an uh, web portal through which we are maintaining the Cisco Epic EM. Cisco Epic EM is the physical box for the Cisco SD-Access. This physical box is maintaining the entire campus network, and we are providing the instructions from the DNA into your Cisco Epic EM. Through that, we are maintaining the entire network. So guys, this is the overview about the Cisco SD-Access. And the next slide, I will log into the Cisco DNA and I will show you, a little bit about how you can play around with the Cisco DNA. Okay, and subsequently I will be adding more videos so that you have a clear understanding about the Cisco SD-Access, exactly what it is. Okay, so this is just an overview, and if you have any comment or if you would like to know anything, just comment below section and I will provide you answer to those questions. Okay, thank you guys.